Welcome to The Explainer. Today, we're zooming in on a topic that, might sound a little intimidating at first glance, but I promise you it's actually one of the most elegantly simple and literally powerful tools humanity's ever invented. We're going to demystify linear equations.
Imagine you're walking along a straight path at a perfectly steady, unchanging pace. Every single step covers the exact same distance. Every minute that ticks by means you've traveled a predictable amount further. Now, what if I told you that you could use that exact same logic to accurately predict the future? Seriously, what if you could forecast real-world outcomes using basically a simple mathematical seesaw? Stick with me, because that is exactly what we're unpacking today.
Okay, let's dive right in. A linear equation is essentially the mathematical language we use to describe a perfectly steady, constant change. It models situations where there are absolutely no sudden jumps, no unexpected drops, and zero wild curves. It's just a reliable, straight-line progression from point A to point B.
At its core, working with this concept is honestly just like solving a beautifully balanced puzzle on a seesaw. If you know the total weight on one side of that seesaw, and you've got a few clues about the weights on the other side, well, you can logically deduce the missing piece, right? The equation just represents that state of perfect balance. It lets us use what we already know to uncover hidden information. We literally work backwards, step by step, making absolutely sure both sides of our mathematical seesaw stay perfectly level.
So why is this so incredibly powerful? Because it actually gives us the ability to accurately predict the future in everyday scenarios. Think about it. Whether you're trying to forecast exactly how much a taxi ride is going to cost before you even open the car door, or maybe you need to estimate how long it'll take to fill a massive swimming pool using just a standard garden hose, this mathematical tool gives you the certainty you need. It gives us the power to take the messy, unpredictable moving parts of real life and turn them into clean, perfectly predictable straight line.
Section 1. Math in your daily life. Let's bring this down to earth and see just how often you interact with this math without even realizing it.
These constant rate relationships seriously govern so much of how our society operates. Think about your mobile phone plan. You are paying a fixed monthly rental fee, plus a specific charge for every extra gigabyte of data you use. Guess what? That's a linear equation. Budgeting a big event? You're adding a fixed hall rental fee to a cost per guest. Jumping in a taxi? That's a fixed starting fare plus a steady rate per kilometer. Or how about a gym membership where you pay an upfront joining fee plus a monthly subscription times 12 months? We see these combinations of fixed and variable costs literally everywhere.
And the list just keeps going. The formula your weather app uses to flawlessly convert Celsius to Fahrenheit, it perfectly follows a straight-line relationship. Same thing goes for estimating your arrival time on a road trip based on your steady cruising speed. Or an hourly wage where you're multiplying a fixed rate by hours worked. Your utility bills follow these rules. It even dictates how you bake. If you're scaling a recipe and you know, okay, 1 cup of rice needs 2 cups of water, you automatically know 3 cups of rice will need exactly 6 cups of water. Even the currency exchange at the airport counter operates on these exact same steady rules.
Section 2. Variables and solving puzzles. Now that we see how everywhere these relationships are, let's shift gears and look at how we actually use mathematical rules to solve these everyday puzzles.
Now, what's really interesting here is contrasting two completely different types of real-world puzzles. On the one hand, you have a solitary unknown, like, say, buying snacks. On the other hand, you have linked quantities, like buying cinema tickets with a whole group of people. Let's break down exactly how our brains naturally process these two different scenarios.
Let's look at the snack scenario first. This is a linear equation in one variable, meaning an equation with only one unknown value. Imagine you hand a crisp $20 bill to the cashier at the school canteen. You grab a sandwich for $5 and you decide you want to spend the exact rest of your money on juice boxes, which are $3 each. To figure out how many juice boxes you can buy, which is our unknown, the x, you instinctively solve the equation 3x plus 5 equals 20 right there in your head. You subtract the $5 sandwich, which leaves you with $15, and then you divide that by $3 a box to get 5 boxes. Boom. You just balance the seesaw.
But what happens when things get slightly more complex? Imagine an equation linking two unknown, changing quantities. You've got a strict budget of $50 for a family movie outing. Adult tickets cost $10 and child tickets cost $5. The combination of how many adults and children can go depends entirely on balancing the equation 10x plus 5y equals 50. If more adults go, well, fewer children can go. It maintains this perfect straight-line relationship balancing precisely on that equation.
Section 3. Graphs, slopes, and systems. So we've got the equations down, but how do we map them out visually to really understand the bigger picture?
Think about plotting a high-speed train's journey.
If you're sitting on a train traveling at a completely constant speed, and you plot the time that's passed on the horizontal axis and the distance covered on the vertical axis, your graph is going to be a perfectly straight line shooting upwards. And this brilliantly illustrates the core concept here. The visual graph actively proves that the speed of the train never changes. It is the perfect visual representation of steady, constant change.
Now let's pit two lines against each other. Imagine you're comparing two streaming services. Service A charges a $10 setup fee plus $5 a month. Service B, no setup fee, but they charge $7 a month. So when will the costs actually match? Month 1, Service A is $15, B is just $7. But look at month 5. Service A is $35 and Service B is also $35.
So the crucial point is this: when you find that exact month where both services cost the exact same amount of money, you're actually doing something incredibly advanced. You are solving a system of linear equations, which you might also know as simultaneous equations. You're finding the precise point in time and space where two perfectly straight lines intersect.
To truly understand these intersecting lines, though, we have to understand their steepness. We call this the slope, or the gradient. It's calculated super simply as the rise, which is the vertical change, divided by the run, the horizontal change. In math formulas, you're almost always going to see this represented by the letter m. It is a precise measure of just how sharply a line goes up or down.
And you know, slope isn't just some abstract concept. It has massive real-world implications. Take wheelchair ramps in public buildings, for example. For a ramp to be safe and legally compliant, it absolutely must have a very specific steepness. Engineers literally calculate this by dividing the height of the steps, the rise, by the horizontal length of the ramp, the run. This strict legal compliance is literally the slope of a linear equation in action in the physical world around us.
Section 4. The backbone of success. We've seen how this math operates in daily life and physical architecture. Now let's explore how these principles are the absolute backbone of high-stakes career and exam success.
Mastering linear equations is the absolute starting point for highly skilled modern workforce problem solving. Want to program AI? You are going to rely heavily on linear regression, which is a machine learning technique predicting future data based on, you guessed it, linear equations. Civil engineers use these exact same principles to calculate stress loads on building beams. Financial analysts use them every day to forecast stock market trends and future company profits. It's literally everywhere.
And for ambitious students, the stakes are even higher. To crack prestigious entrance exams, whether we're talking about the IIT JEE, NEET, BITSAT, IISER, or NEST, extreme proficiency in linear equations is absolutely non-negotiable. Your fluency in this mathematical language is going to directly determine your success.
Let's move on and see how this builds, because this foundational knowledge leads right into even more complex territory. You literally cannot do advanced physics, like kinematics, Kirchhoff's laws, and circuit analysis, or thermodynamics, without rapidly setting up and solving linear relationships. In mathematics, it is the fundamental prerequisite for advanced topics like matrices, determinants, vector algebra, and 3D geometry. Ultimately, recognizing the hidden matrix of these formulas translates directly to exam success. The speed and accuracy with which you can solve a system of linear variables gives you a distinct competitive edge. It saves you precious minutes during high-pressure exams, putting you miles ahead of peers who might still be fumbling with the basic balance of the seesaw.
We've covered a massive amount of ground today, from taxi fares to artificial intelligence, all connected by a simple, straight line. So I want to leave you with this final provocative thought. Now that you can see the linear equations secretly governing our world, how will you use this mathematical seesaw to predict and build your own future? Thank you so much for joining me on this explainer. Stay curious, stay focused, and keep learning.